Hello and welcome to the Metamorphic Rock Identification Lab. My name is Oliver Millington and I will be walking you through the procedure. The first thing we will need to do is gather the materials for the lab. This lab in particular calls for a plastic dual magnifier and the Rockset Metamorphic Rock Identification 8 pieces. As you can see here, I already have those two items ready to go. The procedure is laid out simply in HOL Science Interactive. Gather the metamorphic rock set and hand lens from the lab kit. Arrange 8 metamorphic rock specimens in numerical order in a well-lit area. Beginning with sample number 43, observe each rock for foliation. Refer to figure 6 in the background for examples of foliated textures. Record each rock as foliated or non-foliated in data table 1. Observe each specimen with the hand lens to determine the grain size of crystals. Note, medium grains are sand-sized. Fine grains require magnification with the hand lens for viewing. Record the grain size as no visible grains, fine-grained, medium-grained, or coarse-grained in data table 1. Observe each specimen for distinctive features related to cleavage type, color, or luster, and mineral content. Refer to figure 8 for common minerals found in the metamorphic rock specimens. This image depicts figure 9, which I will be using as my primary tool to identify the metamorphic rocks in the Rockset Metamorphic 8 piece. Much of the vocabulary that I use throughout this video will be taken directly from this figure 9 chart. The first specimen to be identified is specimen 43. Specimen 43 is foliated. It has fine grains or no visible grains. It has flat cleavage and a dull luster. I determined this specimen to be slate. The second rock I will be identifying is specimen number 44. This rock is foliated. It has fine or no visible grains, and it has wavy cleavage. And as you can see when I flip the rock over, it does have a metallic luster to it. I determined from figure 9 that this specific specimen is phyllite. The next specimen I will be identifying is specimen number 45. Specimen number 45 is foliated. It has medium to coarse grain size. It has scaly foliation surfaces and muscovite. I identified this particular specimen as schist. The next specimen I will be identifying is specimen number 46. 46 has some nice lines on it. It is foliated. It is medium to coarse grained. It has banded mineral layers and quartz and hornblende. I identified this rock to be gneiss. Specimen number 47 is non-foliated. It is medium to coarse grained, tightly fused quartz sand grains. I identified this rock as quartzite. Specimen number 48 is also non-foliated. It has medium to coarse grains. It has equal-sized calcite crystals. I identified this specimen to be marble. Specimen number 49 is non-foliated. It has fine grains or no visible grains. It has a microcrystalline dull color. It's hard. I determined that this specimen is hornfels. Last but not least, I have specimen 50. Specimen 50 was probably the easiest specimen to identify. It's non-foliated. It is fine-grained or has no visible grains. It has a glassy texture and uneven features. I identified this specimen as anthracite coal. After determining which specimen was which metamorphic rock, I recorded my results into data table 1, which is pictured below. After recording our data in the table, we will now answer some lab follow-up questions. The first question is, what is recrystallization? Which specimen exhibits the recrystallization of the mineral calcite? My answer to this question was recrystallization is a process where existing minerals rearrange to create new and usually larger crystals because of numerous geological factors, including changes in temperature, pressure, or chemical conditions. Marble, for example, represents the recrystallization of calcite. The second question is, what is a protolith? Which specimen has sandstone as its protolith? A protolith, put simply, is a parent rock from which a metamorphic rock is formed. Sandstone, for example, is a protolith to quartzite. The third question, what are foliations? Which metamorphic process, regional or contact, results in foliations? And which specimens exhibit foliation? Well, foliation refers to the parallel alignment of mineral grains, creating a banded appearance. Foliation can be caused by either shearing forces or differential pressure during regional metamorphism. Gneiss was the specimen in this experiment which best demonstrated foliation. Finally, what is schistosity? Which specimen exhibits schistosity? And what metamorphic mineral process is responsible for the specimen's appearance? Schistosity is a type of foliation in which platy materials cause the rock to easily split into thin sheets. Schistosity is caused by regional metamorphism and differential stress. Schist was a specimen in this experiment which displayed schistosity.